Hello, everyone. It's my pleasure to introduce the next speaker, a fellow Appsilonian, Filip Akkad. Filip is a software engineer at Appsilon who's been exploring how to split monolithic Shiny applications with a React front end and a Shiny backend. So without further delay, please welcome Filip with his presentation, React front end for Shiny applications. Hi, Filip.
Hi everyone. Thanks for having me. Starting from the beginning. So today I would like to share with you my experience in embedding React in Shiny. And so some time ago, when drinking my morning coffee and reading about new cool features of React, I finally decided that I need to try it with Shiny. So here I've listed some of my motivation at the time. We can call it the success criteria or goals as well. So the first motivation for me is to improve your user experience, providing a clear separation of the operations performed by the Shiny server and the browser, so that I will have a better control over the page dynamics and avoid unnecessary UI blocking. I wanted to design frontend according to the best modern standards and patterns using widely adopted technology. And the spoiler here, I'm talking about React, but also other concepts like component-driven development or atomic design. And the third point, I wanted to keep deploying my application as a single bundle. So in order to make it worth the overhead of using React should be as small as possible for the developer. And last but not least is I wanted to avoid an exotic or unstable workarounds or hacking. So my dream goal was to change the way of thinking about Shiny application, its architecture, instead of just introducing another new package. So does it really have to be a monolith? Maybe not. So from practical point of view, I just wanted to stick only to the Shiny package and avoid unstable dependencies. But also, I wanted to display ggplot rendered in R, considering its importance for Shiny users, design reusable UI components, and apply static typing to my JavaScript code. And it's personal. I'm just a huge fan of TypeScript. But what is React.js? So briefly speaking, we don't have much time to go in details, talk about in details, but briefly speaking, it's an open source JavaScript library for building user interfaces created and maintained and used by Facebook. So regardless of the company itself, the situation where an open source technology is strongly backed by a large entity is quite beneficial and provides more stability and reliability for its users. And React comes with two key features that add to its appeal for JavaScript developers. So JSX, short for JavaScript extension, it just makes it easy for web developers to modify the DOM using simple HTML style code. So as you can see on the slide, those two pieces of code are equivalent. And the virtual DOM. So since virtual DOM is more of a pattern than a specific technology, people sometimes say it to mean different things. So if you're not using React.js and JSX, your website will use HTML to update its DOM. This works fine for simple static websites, but for dynamic websites that involve heavy user interaction, it can become a problem since the entire DOM needs to reload every time the user clicks a feature calling for a page refresh. However, if a developer uses JSX to manipulate and update its DOM, React.js creates something called a virtual DOM. A virtual DOM, like the name implies, is a copy of the site's DOM, and React.js uses this copy to see what parts of the actual DOM needs to change when an event happens, like a user clicking a button. So let's say a user enters a comment in a blog post and pushes the comment button. Without using React.js, the entire DOM would have to update to reflect this change. React, on the other hand, scans the virtual DOM to see what changed after the user action, in this case, a comment being added, and selectively updates the section of the DOM only. So this kind of selecting updating takes less computing power and less loading time, which might not sound like much when you're talking about a single block comment. But when you start to think about all the dynamics and updating of even slightly complex website, you will realize it adds up a lot. And React has a huge community. So over the past few years, React community grew a lot, which means that most of the problems that you may face during the development were likely already solved. On the graph, you can see the number of questions posted on Stack Overflow over time. So now you can see that React community is leading among other UI frameworks. And here I wanted to show you an example which might be pretty useful in our Shiny applications, especially when working with a large data sets. So UI virtualization is a general front-end concept whereby only the amount of data visible in the user's viewport is being rendered rather than adding all DOM elements at once. And React Window is a cool library implementing this concept. Look how smoothly the scrolling works for 100,000 rows, preserving more or less the same amount of DOM elements seen on the right. So, knowing how cool React is, the obvious question that came to my mind were, is it possible to split the monolithic Shiny application into React frontend and Shiny backend and still keep it deployable as one bundle, like for example to RStudio Connect or Shiny apps? The simple answer is yes, but how? Here, I would like to present you the dummy implementation of the concept. So first, you create and build your React app. I am aware how general this point sounds for now, but let's assume you've developed and built your React app for now. By that, I mean that your build folder contains a standalone static web page, along with some JS, CSS, and other resources. I'll address this point later in the presentation when talking about the tools you may use. The second point will be to link the Shiny UI to the static React app. You can achieve this by with the two functions coming from Shiny package. The first one is add resource path. So you are linking the React static assets to the Shiny application, and Shiny HTML template function. So as you can see, the UI function is pretty small, and it just points to the React app. And the React app contains all the necessary dependencies through the head content function used in HTML template. So when the session is over, you can notice this characteristic gray page and a notification about reloading the session. The next question that may arise is how actually Shiny and React can talk to each other. And I distinguish three ways. The first two ones are based on WebSocket, and they are well described and documented in RStudio website. So from Shiny to React, you just use send custom message method on session object, and then on the React side, you just listen for this message with add custom message handler. And in this example, this value has been set with the React hooks, use state hooks. On the other hand, from the message coming from React to Shiny is being sent with set input value method on Shiny object in JS, and then on Shiny side, it's just being the observe event is just listening to the input, and in this case, it's printing this value. There is a third option, and we don't have enough time to discuss it in details, but for now, I just want to highlight that Shiny offers a dynamic REST API endpoints out of the box, which I know there was a talk about it, and it's pretty useful when implementing the concept and embedding React in Shiny. So let me go to the demo, but I will use my local my local instance. So here you have a very simple application. Those who already worked with React may notice the characteristic logo of React, and the temp theme coming from Create React App. And in fact, it has been initialized with Create React App. So this app aims to show two things. First, the communication through WebSocket, and this notice I'm typing hello community, and I can see this very useful notification popping up. On the other hand, in the logs, you may see that the message has been sent successfully. The second thing I wanted to show you is that you can actually display ggplot in the app, and you can update the title or modify the plot. In this case, it's just updating the title with Shiny REST API. The last example is to show you something similar you've seen on the GIF, which is a virtualized list of 500,000 rows generated in R using random names package. And yeah, it's generating first 500,000 rows. And you can see the table here and take a look how smoothly it is working. You can just scroll down 500,000 rows and without any delay. Okay, so coming back to the presentation. So, yeah. So, as mentioned before, or maybe not, but creating React app itself and embedding it in Shiny requires some prior configuration. So in most cases, it's just one-time job. So in order to make it simpler for the Shiny developers, I've created a template providing a simple pre-configured React and Shiny app you can customize according to your needs. There is also a detailed README where you can learn more about the setup as well as some examples. For instance, you may want to look at the REST API section that I mentioned before and its usage together with React. And it's good to emphasize, I guess, that the template does not require any specific R package to work. It's just a slightly squeezed Shiny. The challenge was, and perhaps still is, how to connect it with React in the most maintainable, clean way without compromising developers' experience. Therefore, I would like to invite you to take a look at the template and give your feedback. But that's not over yet. So the approach I presented makes a React app a fully fledged frontend for your Shiny application. Naturally, it would require from you to know or learn JS and React, to which I strongly encourage you. But I am aware that not everyone is such a React freak like me. So if you're not so much into JS and still would like to use some of the React UI libraries, for example, Material UI, you may certainly be interested in porting them with Shiny React package developed by Appsilon, or use the existing UI packages like Shiny Fluent based on Microsoft Fluent UI. Concluding. So my goal here today was to convince you that it's entirely possible to use pure React hand-in-hand with Shiny on the backend and take advantage of the latest modern front-end tools and techniques when creating your apps. Let me know if I've managed to achieve this goal or at least spark your interest in React. And if you have any questions, doubts, or you'd like just to have a virtual coffee, please ping me on LinkedIn or email. Thank you.
Wow, so cool, Philip. That's very cool. So as a self-proclaimed React freak, I've got a question for you here. To anyone who wants to get started playing around with React, where would be a good place to start learning, in your opinion?
I would start with simple Create React App framework or the way of initializing the project. React has a very good documentation, and I feel it's the developer experience of React is really good, and there is tons of material. So I would start with an official documentation, and then case by case, go deeper into some more detailed articles.
Great. And are there any features of React that you have not been able to utilize using this method?
It's React. It's a pure React. So you can use whatever is possible in React is possible in this approach because it's just a React. It's not the shiny flavored React or whatever. It's just a pure React. So you can do anything. So yeah, no. The answer is no.
Great. And for unnecessary UI blocking, can you give examples of when you think this is most necessary?
For example, when okay, so there is an example of huge drop-down select types drop-downs. So for a few times I faced a situation when where I had a very large list of names of genes because it was a pharmaceutical project, and it took some time to render this list. And when I was trying to scroll down, it was like first it was rendering for a long time. Then scrolling this took also some significant amount of time. So yeah, this was the case when I could really use some virtualization at the time. Yeah, but on the other hand, yes, for the UI blocking, anything that involves Shiny Server for generating UI, I guess, and I am advocating not to use Shiny Server for UI. So just keep backend operations for the backend and keep UI and front-end operation for the backend. And unfortunately, I mean, there are a lot of operations where the Shiny Server, I guess, and I feel is unnecessarily involved.
And when we get large amounts of columns, can React handle it smoothly?
Yeah, I mean, yeah. Of course, it depends how many columns. It's not like easy answer, but generally, yes. I mean, yeah.
Right. And could it be possible to also link Angular and Shiny?
I don't know. So the main, I'm not an expert in Angular, but if it's not a React-specific solution in a sense that whatever static application you can generate, you can embed it in Shiny. So if you can create a static web page from Angular, then of course you can use Angular. But I'm not sure if that's possible. I'm not an expert in Angular.
So maybe next talk.
Yeah,
next conference.
certainly.
And as we have some time, could you do a short demo of how to generate this ggplot with REST API? I'm not sure if that'll be possible, but
yeah, let me open I'll try to do my best. So let me open this template. So here you have some examples, and I think I have one about the ggplot. I hope so. If not here, then in the code. So in general, the way how this ggplot is being rendered is just a simple image. For React, it's a simple image that is being rendered. It could be a photo or anything else. But how R is being, it's more interesting to see how R is being used here. Okay, here I create an endpoint. Here, take a look at this piece. So here I'm creating an endpoint for getting the plot. I'm taking some parameters. In this case, the only parameter was a title, but you can extend it to any other parameter. And then I'm just saving this plot and reading it as an SVG file and send it back through the HTTP response. So yeah.
And Philip, could you enlarge the text?
Sorry.
Cool. Thanks.
Yeah. So again, here is the parsing the query parameters with some title in this case, and here I'm just saving this ggplot and reading it as a binary file and sending back to the React as a response with this MIME option, which is image SVG. So this is basically it. You can do the same with any other image, basically.
So
I hope that, yeah.
Regarding Shiny API, can we use any type of R-generated graphics?
Yeah, I mean, I would say so. I would take a risk and say so, because whatever graphics is being generated is just ultimately it's just JPG or PNG or whatever format it is. As long as it is being servable by the MIME, it's completely fine.
And here's another question from the chat. Do you consider with this integration that there's no limits on what any front-end developer would design interacting with R?
I don't see the limits on the front-end side, but I can see the challenge how to approach the appropriate communication between React and Shiny, because as I can show you in the graph, you need to take a more think a bit about how to appropriate make them talk with each other using the techniques that I showed you. In this simple example, I just created, this flow of exchanging the URL with React, because React must know somehow how to which URL to use, which endpoint to use to get the resource. So it needs to be it needs to know it from the very beginning, and it's not obvious because first Shiny needs to send this information to the React side, then React has to consume it, and then switch from WebSocket to using REST API. So this is the challenge I would see, like a backend frontend challenge. But then once what is being put together, then I feel there is there's no more challenges than in the standard frontend React app.
Okay. And maybe one last question here. As you're creating endpoints of an API REST to interact with React, wouldn't it be easier to use Plumber instead of Shiny? What advantages are here in using Shiny?
So my goal was to create like a single bundle so that I am able to deploy my application as one piece. With Plumber, you would have to have a separate server for your React app. This is one first thing. The second thing I have not identified the advantage is the WebSocket coming out of the box with Shiny. So with a Plumber, the React is calling for an action. But with Shiny, it's a server that can call the action using WebSocket. It can send message to the front end using WebSocket. I don't feel, and I haven't found a way to do it like in an easy way with Plumber. I tried to explain this here at the very end on the fact how does Shiny REST API approach differ from Plumber. Hope that it gives a bit more feeling about the answer.
That's great. So if there are any more questions in the chat, feel free to keep asking them, and we'll try to answer them later. So Philip, one last question. I see you have your LinkedIn and your Gmail there. What's the best way for folks to reach out to you?
I was a bit nervous before the presentation. I wanted to type my Appsilon account. It's not even the logo, so sorry for that. You can reach me under this link in LinkedIn, in Gmail, but also with an Appsilon account. So the same email address, but with an appsilon.com at the very end.
Great. Well, thank you so much, Philip. I appreciate it.
Thank you for having me.